Hi, welcome to another video in the Designing on Particles series, in which we walk through best practices and recommendations as you build your particle-based product. My name is Manuel Orduño, Solutions Architect here at Particle, and in this video we will cover one of the core parts of our platform, the IoT data pipeline. Probably one of the most important reasons you're creating an IoT product is because you want to be able to gather data from your field devices and monitor or process it in your cloud system. Through the Particle Device Cloud, we offer a secure, scalable, and easy-to-use foundation to do just that. So throughout this video, we will discuss the architecture of our data pipeline and the advantages it gives us. Then we will learn how to send data from your devices starting at the firmware level, discussing the publish and subscribe APIs, and going over tips to avoid potential mistakes. Lastly, we will discuss integrations, which is a way in which you can easily interact with our cloud to get device data into your own systems. We will go over the different integrations at your disposal, touching on some of the pros and cons each of them have. This is part 1 of a 2-part series. This video will focus on the theory side of our data pipeline, while the second video will put these concepts in practice to build a scalable architecture to send and receive data. By the end of these videos, you'll have a solid understanding of how to apply all this in your systems. Let's get started. First, let's understand at a high level how our bidirectional data pipeline works. As we discussed before, the Particle platform provides an easy mechanism to integrate with virtually any cloud platform you can think of. Let's take a look under the hood to get a better understanding of what happens behind the scenes. First, devices send or receive data using publish and subscribe respectively, two APIs that provide secure, scalable, and efficient data transmission. Our APIs abstract away the differences across radio technologies and different modules, offering the same experience across our product line. Second, data is encrypted and sent over CoAP, which offers multiple advantages over other transfer protocols. For example, it minimizes the required data usage and allows us to have a reduced ping frequency while still enabling a device to be reached by the cloud instantly. Third, our platform will handle retransmissions when devices with poor connectivity require it, as well as load balancing requests to ensure a low latency experience even with thousands of devices simultaneously publishing or receiving data. Finally, you can subscribe to these events through HTTP webhooks or server-sent events. As you can see, this architecture provides a scalable and secure pipeline to power your own cloud needs. To conclude, I want to mention a few things to keep in mind regarding our data pipeline. A single line of code gives you a reliable and secure bidirectional mechanism to funnel data in and out of your tools. Not having to worry about this is a major benefit as you focus on your business logic. We don't store your payloads, we merely route them to your systems. The only exception to this is when working with our asset tracker platform, and even then you can opt out of this. We will only bill for a device-to-cloud event, which encompass our 4 cloud primitives: publish, subscribe, function, and variable. This means, for example, that a publishing event can trigger both a write to a time series database as well as to a real-time alerting system and would only consume one data operation. Now that we have a general understanding of our data pipeline, let's go over some practical details to use it in your projects, starting at the device level with the Particle.publish and subscribe APIs. As we learned on previous videos, Particle Publish is used to send an event through the Particle Device Cloud that will be forwarded to all registered listeners such as webhooks, streams of server-sent events, and other devices listening via Particle Subscribe. It is arguably one of our most useful device APIs. However, there are a few things to be aware of. Events have a maximum publish rate of 1 publish per second, so it's not suited for stream-like use cases. Also, there's a maximum payload size of 1024 characters per publish. If you need to send larger payloads, you'll have to chunk your messages to fit within that limit. Always text encode your payloads. While working with text-based data like JSON is easier, if you need to send binary data, convert it to text first using base64, for example. Each event will typically use one data operation. though occasional exceptions can happen if you set the acknowledge flag and an event gets lost and must be retransmitted. Please refer to our documentation for further details on Particle Publish. Particle Subscribe allows the cloud to send an event to many devices. It is similar to the function primitive. However, it has the advantage of allowing a single event to reach hundreds of devices, making it more powerful than functions which are scoped to individual devices. As with Particle Publish, there are important considerations to be aware of when using Subscribe. Subscriptions work like prefix filters. This powerful feature allows us to define different levels of scope to reach either all of your devices, a subset of devices, or a single device. While a device can only subscribe to 4 topics, the prefix engine means we can accept many events with a single subscription. A small difference between using Subscribe versus a function is that with Subscribe there is no built-in acknowledgement, but it's definitely possible to implement that behavior in your cloud. Lastly, large responses will be chunked in 512-byte parts, each consuming 1 data operation. So ideally, responses should be short or shortened in the cloud before being sent to your devices. If you'd like to learn more about how to use these prefix filters more effectively, please check out our in-depth guide in the description. The events log provides an interface to view event information in real time. Essentially, anytime one of your devices publishes data, you should see a record appear on the stream. This tool comes in handy both while debugging code during development and also to check out recent activity on your production fleet. Keep in mind that because of the ephemeral nature of our events architecture, you'll only see events coming in while the browser window is open. Okay, so now that we have programmed our devices to publish data and we're seeing those messages appear in the console, it's time for us to learn how to actually route them into your own systems. And for that, we use integrations. Integrations provide a way of easily interacting with internet-based services, taking advantage of the authentication and encryption already provided with the Particle Cloud connection. Particle puts 2 types of integrations at your disposal: webhooks and server-sent events. Webhooks rely on making outgoing HTTP requests from the Particle Cloud to your own servers, so you can consider each request as a short-lived transaction. In contrast, SSE consists of your server making an outbound connection to our cloud that will remain open and all incoming events will be sent down the stream. As with most engineering questions, which method is the best for you will depend on a number of factors, though we generally recommend webhooks for various reasons. For example, on SSE, the connection can be closed at any time by the Particle Cloud. You must be able to handle this and reconnect. Also, there's a limit to the number of open requests and simultaneous connections you can make, which could become a problem as you scale. This being said, it'll ultimately depend on your own cloud architecture and what you feel most comfortable working with. Our documentation has additional information on each of these 2 methods. Particle offers multiple types of integrations. For starters, we have first-class integrations made in conjunction with Microsoft and Google to further simplify the process of sending and receiving data from their respective platforms. But if you need to integrate instead to AWS, don't worry. Our general-purpose webhook engine makes it super simple to connect to AWS or any other HTTP-supported service. Please refer to our documentation to learn more about our first-class integrations. Let's continue to learn more about our webhook engine. Particle's Webhook Builder is a generic but powerful tool that lets you integrate with pretty much any platform that supports standard web requests. Found right inside the console, this Webhook Builder allows you to specify things like the publishing event, the target URL, contents of the body, among other things. The Webhook Builder is great to get started, but our webhook engine has features to support more advanced requirements like JSON editing and webhook management from either the CLI or the API. The concept of predefined variables, things like a device ID or product ID, which you can insert at any field within the webhook. And we also support Mustache templates that allow you to do powerful variable substitutions of JSON data for cases in which you need to reformat either the web request or the server response. Please refer to our documentation for additional information on these advanced topics. As your fleet scales, you'll probably want to monitor your integrations to ensure that your data traffic is running smoothly. Fortunately, our fully integrated diagnostics let you monitor your webhook activity, so you'll always know if something's wrong. Our integrations page gives you a thorough logs of the 10 most recent webhooks, as well as a 30-day history for broader inspection. With all this information, the vast majority of issues can be easily identified and dealt with. Please refer to this guide to learn more on troubleshooting webhooks. And this is it. I know we covered a lot of topics, so let's take a step back and do a quick recap to tie everything together before moving on. First, we did an overview of the particle data pipeline. What are its key features and how it gives you the tools necessary to send data back and forth your fleet of devices. Then, we introduced the publish and subscribe APIs and how to use them correctly to create a scalable messaging architecture. Finally, we learned about the different integrations that we provide, how to choose the best one for your application, and what tools are at your disposal to monitor their health. Our secure, integrated, and reliable stack solves the hidden challenges of device-to-cloud communication for you. In our next video, we'll see a practical example of these concepts as we build an integration for a popular IoT dashboard and analytics platform. Thanks for watching. Until the next time.